All right, so we're going to talk about vertex form. What's going to happen is I'm going to give you an equation. Y equals a parentheses x minus h quantity squared plus k. And that's kind of the form that we worked with already. All right. So what we're going to do is from that equation, we're going to figure out where my vertex is, what my axis of symmetry is, my y-intercept, my domain, my range, where my graph is increasing and decreasing, and the direction of the opening. All right, those are all the things we're going to figure out. All right, and as we go through, I'm going to type them up here and add them if I haven't already done so. All right, so first, my vertex is going to be x comma k, or I'm sorry, h comma k. All right, and we've done that. This past lesson, we took the opposite of the number on the inside, comma the number on the outside. Since this is negative, we did the opposite. That's my vertex. All right, so we're going to get some point that we're going to call our vertex. All right, we're going to have a parabola. This is going to be the ordered pair, h comma k. All right, don't worry about this problem yet. Don't get ahead of me. All right, next, my axis of symmetry. My axis of symmetry is going to be a vertical line that goes through my vertex. That's going to split my graph in half. This is the reason we don't have to plug all the numbers in because they match up. This equation is going to be the line x equals h. My axis of symmetry is going to be the line x equals h. And that h is going to come from the vertex. All right, so once I get my vertex, I'm going to set x equal to h, and that's going to be my axis of symmetry. All right, the number in the front. If my a value in front of my parentheses is greater than 0, which is a positive number, my graph is going to open up. All right, so write that down. If my a value is greater than 0, it opens up. If my a value is less than 0, it's going to open down. That's going to be my direction. If my a value is greater than 0, which is a positive number, my graph is going to go up. If my a value is less than 0, it's going to go down. And again, I have way too many people without their cameras on. So that's going to take care of these two. All right, my y-intercept. What do we know about all y-intercepts? What do we know about all the ordered pairs for my y-intercepts? Where my graph crosses the y-axis. And we did this a couple lessons ago when we were graphing lines.
There's a 0 next.
Exactly. For every single y-intercept, my x equals 0. All right, and the last bit we're going to write down here. All right, for increasing and decreasing. This is ugly, but it's just how my pen writes. When we talk about increasing and decreasing, the last thing I want you to write down is we write answers in terms of x. And you'll see what that means in a minute. Increasing and decreasing, we're going to write our answers in terms of x. All right, so, tonight's homework, you have 7 problems, I believe. On those 7 problems, I want you to do this, and that's all you have to do. Do not follow the directions in the worksheet I give you. Or I'll probably put on there, but if it came out of the book, do not follow the directions. Do what we're doing here. I want you to find these 8 things. We're going to find the vertex, x of the symmetry, the y-intercept, the domain of the range, increasing, decreasing in the direction of the opening. All right, so going through it, we're going to get the vertex like we did last class. The opposite of the inside, comma, the number on the outside. My axis of symmetry is going to be the vertical line that goes through the vertex. X equals my h value that I get from my x value of my vertex. If the number in front of my parentheses is positive, it goes up. If it's negative, it goes down. Domain and range we know how to figure out. The y-intercept, we're going to set x equal to 0. And the increasing and decreasing we'll talk about when we get there. All right, so let me get rid of some of this. All right, and write down number 5 for me. This is A. Okay, we'll talk about it in relation to our problem in a second. A is going to be the number in front of the parentheses. All right, so we're going to find 2 things first. Out of all 8 of these, we're going to find the vertex and the direction first. And we'll talk about the A of S also. I'm sorry, I thought I said find A. I didn't read the rest of it. The axis of symmetry, we'll find it in a second. Okay? The A of S is my axis of symmetry. I just didn't want to write it all out. Axis of symmetry. It's going to be the vertical line that splits the graph in half. And what we're going to do is, we're going to take x equals h. All right, so looking at this, and we'll talk about all of the steps as we go through. What's my vertex? Someone chat me the vertex of this parabola. Based on last night's homework, it is not negative 1, 2. HK, okay, what is my HK? There we go, someone got it. It's going to be 1, 2. We take the opposite of the inside, comma the number on the outside. All right, so my vertex is the ordered pair 1, 2. The opposite of this, comma the number on the outside. That was 8 problems for homework yesterday. That should have been done the same way. All right, because my A value is a positive 4, is my graph going to open up or is it going to open down? It's going to open up. It's a positive number, so it opens up. So what I'm going to do, I'm going to come over here to a basic graph. And it's not going to be pretty and perfect, but it's going to be good enough. I'm going to plot the point 1, 2. And draw a parabola that opens up. All right. So I'm going to make a basic graph of a parabola that has a vertex of 1, 2 that opens up. That's going to help me find some of my other stuff. All right, my axis of symmetry, my A of S, is a line. It's not a number, it's a line. The equation of that line is going to be x equals some number. Okay, the axis of symmetry is going to be the equation of a line, x equals some number, and it's going to be this line right here that goes through the vertex. So if my x value is my axis of symmetry that goes through this vertex, 1, 2, my axis of symmetry is going to be x equals 1. Because that's the vertical line x equals. All right, so I take the x value of my vertex and use it for my axis of symmetry. We're going to use these numbers, 1 and 2, a bunch in this problem. All right, y-intercept. We said to find the y-intercept, we make x equals 0. So I'm going to take, let me erase some stuff because it's getting ugly. This equation and put a 0 into x. And evaluate. So to find my y-intercept, I'm going to make x equal to 0. Plug into 0 and evaluate. And my graph is not going to look right because I didn't really do an exact one. I just made a basic shape because mine's not going to have the same y-intercept. All right, so if I do 4 times 0 minus 1 quantity squared, add 2. We got 2 answers. One's right, one's not. Remember, negative 1 squared is a positive 1. Then we're going to say my y-intercept is 6. 0 minus 1 is negative 1. Negative 1 squared is a positive 1. 4 times 1 is 4 plus 2. You don't square the 4 because it's outside. You square the negative 1, then multiply by 4. Okay, and hopefully as we do this, it's just still getting into the swing. All right, so we're good there. All right, what's my domain? What's the domain of this function or graph? And it's something we talked about last class. Absolutely, it's all real numbers. All of the problems we do today, all absolute values and all squares are all real numbers. All right, next is my range. My range is going to be my y values. So look at the graph, the basic sketch, and see what y values we're dealing with. Looking at it, it looks like my graph, the lowest y value I have is at 2, and I want everything above it. So we're going to say that my range is y is greater than or equal to, because 2 is a good value, 2. If you look, my axis of symmetry and my vertex have the same x value. My range and my vertex is based on the same y value. Always going to work that way. Your range is going to be based on your y value of your vertex. Your axis of symmetry is going to be based on the x value of your vertex. All right, and that's the increasing and decreasing. All right, let me erase a little bit over here. Let me just draw it again. Easier. All right, so this is the new part. Increasing and decreasing. So what we want to find in terms of x is I want to know what x values my graphs are increasing and what x values my graph is decreasing. All right, so we're going to look from the left to the right. I'm going to start over here on the graph. As I start going to the right, reading it from the left to the right, is my graph increasing or decreasing on that left side? Is my graph going down from the left to right, or is it going up? It's decreasing, absolutely. As I read it, my graph is going down until it hits this x value. And what is that x value where it changes from decreasing? X value It changes at 1. Right? So for over here, until I hit this point, all of these numbers on the left side of 1, my graph is decreasing. When I get to the other side of 1, and I keep drawing my graph, what's going on the right side of 1? Hopefully we realize it's going up. So we're going to say it's increasing. All right, so I got to decide. Over here, my graph is increasing. Mathematical statement. What values of x has this graph going up or increasing? X's that are what? What are these x's over here? Are they greater than 1 or less than 1? Not just positive, more than that. They're increasing when my x's are greater than 1. I'm starting here and I want all of these values. It keeps going to the right forever where it's increasing. All right, so then that means over here, my graph is decreasing, so I want all the x's that are less than 1. So drawing your picture helps you decide on these. But if you look, and it gets a little ugly over here sometimes, so I keep writing on it to help you out. Your vertex, your axis symmetry, your increasing and decreasing are all going to be based on that 1 of your vertex. Every time. Your 2 value is going to help you with your range. The y value of your vertex is going to give you an idea for your range. The x value of your vertex gives you the axis of symmetry and helps you out with your increasing and decreasing. Increasing will not always be greater. We'll change that up in a minute. No, decreasing and increasing doesn't always... Increasing is not always x greater. Decreasing is not always x is less. That's a 6. That's my bad writing and my bad pen. Okay. All right, so starting at the beginning. It's ugly, but we can work with it. The opposite of the inside, comma the outside, is my vertex. X equals the x value of my vertex is my axis of symmetry. I plugged a 0 into this function right here and evaluated and got my y-intercept. Domain is always going to be all real numbers, and it doesn't look like I can spell main. My range, looking at the graph, it starts at 2 and goes up. Greater than or equal to based on your y value. As I move from the left to the right, first my graph is decreasing because it goes down until I hit 1. So it's all the values less than 1 decreases. And to the right of 1, greater than 1, it's going to increase because it's going up. Yes, the axis of symmetry is, if my ordered pair was 3, if I could write something, how about 4, 7? If my ordered pair was, for my vertex is 4, 7, my axis of symmetry is x equals 4 automatically. All right, and this number in the front, if it's positive, it goes up. If it's negative, it goes down. All right, that's all I want for your homework. Drawing the graph helps, because then you can look at the picture and see what's going on. All right, we'll do one more like this before we add a little bit more to it. And the little bit more is just going to be a basic math to get some of this stuff. Before I move on, if you have a question, make sure you ask. I'm trying to answer them as we go through. All right, let's look at this one. Y equals a negative 2 parentheses x plus 1 quantity squared plus 3. Negative 2 parentheses x plus 1 quantity squared plus 3. And next to it, vertex, axis symmetry, y-intercept, domain, range, increasing, decreasing in the direction. Again, I'll say it one more time. Tonight's homework, I want all 8 of these for the 7 problems we do. And truly, I mean, none of them are like higher math where you got to do a lot of stuff. You just have to know where to get your numbers from. All right, y equals a negative 2 parentheses, x plus 1 quantity squared plus 3. All right, find me a vertex, and then find me a direction. And stop there, don't do more. Find me a vertex. We get our vertex from the opposite here, comma, the number here. So I'm going to say negative 1, 3. Because I have a negative in the front, my graph is going to go down. We don't need to know how far it goes down, we just need to know it opens down. So I'm going to come over to my graph and graph that. I'm going to put a vertex, and then I'm going to draw some parabola that opens down. All right, what we're doing today is another way to graph. What we're doing now is we know how to draw these graphs by making our tables and doing our transformations and everything. So we're not doing all the problems like this. We're just taking a graph that we know how to draw already and talking about it, analyzing it, figuring out what we know about it. All right, so tonight you don't have to draw any good-looking graphs. What I just drew on the board is enough. All right, but you're going to be able to do this same idea that we're doing now with the absolute values also. It's just we're not there yet. All right, so from here, axis of symmetry. Axis of symmetry is always the equation x equals. This line here is the equation x equals, and it goes through the point negative 1 for my x value. So I'm just taking this value and setting it equal to x, and that's my axis of symmetry. That's the vertical line that goes through the vertex that splits the graph in half. So if I fold on that vertical line, everything matches up. All right, do me some quick math. Find me the y-intercept. Yeah, I believe it should be a positive 1, not a negative 1. My pen doesn't like to write for some reason, so that's why it's uglier than normal. All right, so I'm going to plug a 0 into this function, and I'm going to evaluate. I get a positive 1. And my graph's not completely off, but it's not really even close. All right, what's my domain for any quadratic? My domain's going to be always all real. I did. Orders of operations. I do the inside. I get a 1. I square the 1 as my second step, which is my exponent. I get a positive 1. Then I multiply. You get a negative 2. And lastly, I add. Parentheses first, exponents, multiply, addition. The 0, my y-intercept, which is going to be this point, is going to be 0 comma something. All right? All y-intercepts are 0 comma something. That's why I plugged a 0 into the problem. I'm looking at my graph, and based on this 3, my y is going to be greater than or less than and equal to the value 3. It's always going to be based on that x or the y value of this vertex. So is it greater than or less than 3? Do I want the y's greater than 3 or less than 3? And we're going to make it equal to also. So my range, because my graph starts here and goes down, my y's are going to be less than or equal to 3. Because that's the y value of my vertex. All right. My increasing and decreasing, again, is going to be based on the -1 of my vertex all the time. Axis of symmetry, increasing and decreasing, are always based on the x value of your vertex. All right, so as I work from the left side to the right side, and I follow my graph from the left to the right and stop here, is that part of my graph increasing or decreasing? If I work from the left to the right, and I stop at that point, is my graph increasing or decreasing? Absolutely, it's increasing. Now, when I get on the other side of -1, my graph's going to go down. So on the other side of my graph, hopefully we're going to say that my graph is decreasing. So finish these inequalities and tell me what x's it's increasing and what x's it's decreasing. If I get on the graph over here, somewhere on this side, if I move on the graph to the right, and I hit this point, was my graph being drawn up, or is my graph being drawn down? As I work from the left to the right, I'm drawing my graph up until I hit that point. So when I graph up, my graph is increasing. Once I hit that point, I get on the other side and I start drawing it again, my graph is going down, which means it's decreasing. So I look from the left to the right. If I go back to here, as I start drawing on the left until I hit this point, from the left to the right, my graph is going down. And once I hit that point, I get on the other side. If I continue my graph from the left to the right, it's getting bigger and it's increasing. That's how we decide increasing and decreasing. So I'm going to say that my graph is increasing over here, and that's when my x's are less than -1. And on the other side, over here, those are when my x's are greater than -1, because we said over here, this section is increasing, And when it's bigger than -1, it's decreasing. Just follow the graph from the left to the right. Put your pencil on the graph and draw it to the right and see if your graph is going up or down. And where does it stop going up or down? Questions. And that's what we need. We're going to add a little bit more to this in a second. But it's not going to change how we write these answers. It's just going to change how we get some of them. Questions, concerns. If you got some questions you're just not seeing it at all, and I'm not really answering them correctly for you, when we finish, stay back and ask me a question. All right, let's go back to number 1. We did this a little differently than I normally do. All right, so we're going to add a couple things. All right, so this is the same stuff we just talked about, but instead of having it in the HK form, we're going to talk about the equation y equals ax squared plus bx plus c. So we're going to be given a different form to start. We're not going to be able to look at it and tell what our vertex is. We're going to have to do just some basic math. All right, so this is the first thing we're going to copy down. Only copy down what I circle or highlight. All right, my axis of symmetry. We said before was x equals h, but now we're going to say it's x equals negative b over 2a. We're going to have to use the formula negative b divided by 2a to find our axis of symmetry. So x equals negative b divided by 2a is going to be my axis of symmetry, which is going to be pretty simple to do once we see it. And then to get my vertex, we can use the formula as my ordered pair, negative b divided by 2a, comma, f of negative b divided by 2a, which is going to be real simple once we see it. All right? And everything else we did is going to be worked out the same way. We're just going to get our vertex and our axis of symmetry a little bit differently. It's not going to be straight looking at it and pull it out. We're going to find the axis of symmetry, and then we're going to use that to find the vertex. Last time we got the vertex, and it told us what our axis of symmetry was. All right, so the axis of symmetry, x equals negative b over 2a. My vertex is the ordered pair, negative b over 2a, comma, f of negative b over 2a, which is going to be real simple. All right, and everything else is going to be done in the same way. All right, so let's look at number 1. And we're going to do it exactly the same problems that we did before. We're going to find a vertex, axis of symmetry, y-intercept, domain, range, increasing, decreasing, and direction. All right, so before we get going, and as you're writing this down, I want you to find me after you write it down. I want you to find me the direction, the y-intercept, and the domain. All we're writing down on this slide is what I put a square around. We don't need the other stuff. All right. F of x equals x squared minus 2x minus 3. F of x equals x squared minus 2x minus 3. Find me the y-intercept. Find me the domain. Tell me the direction that the graph opens. Tell me if it goes up or if it goes down. And use the same ideas that we did on the first two. Vertex, axis, symmetry, y-intercept, domain, range, increasing, decreasing in the directions. I want, before we even do any real math, or any tough math, the y-intercept, which is a simple thing to find, the domain and the direction. All right, to find my y-intercept, I'm going to put a 0 into my axis and evaluate and get a -3. Did I copy the problem down wrong? My domain is always going to be all real numbers. And my direction is up because I have a positive x squared. Those are the pretty simple ones. All right, everything else is going to be based off of my axis of symmetry. So I'm going to take this, and my axis of symmetry is going to be the equation negative b over 2a. X equals negative b over 2a. We know it's up because my x squared is positive. The axis of symmetry has absolutely nothing to do with what direction it opens. If my x squared, my a value, whatever's in front of that parentheses, is positive, it opens up. All right, so I'm going to say for this problem, my a is 1, my b is a -2, my c is a -3. So I'm going to do negative b over 2 times a. Negative b, so negative -2 over 2 times 1. And I get an axis of symmetry of x equals 1. Negative b over 2a equals x, which is my axis of symmetry. Yes, this math right here tells me my axis of symmetry. Because we said my equation for my axis of symmetry is x equals negative b over 2a. So I'm going to take negative b divided by 2 times a, do my math, which is a -2, which is a +2. 2 times 1 is 2. I get an axis of symmetry of x equals 1. Right, now, that's going to help me finish the problem. What do we know about our vertex? Can anybody tell me anything about the vertex?
The x value is 1.
Absolutely, my x value is 1. My vertex has nothing to do with my y-intercept. My y-intercept is my math of going into here and plugging a 0 into X. Nothing to do with the vertex, completely separate. All right, so now because of my axis of symmetry, I know my vertex is 1 comma something. My vertex is going to be 1 comma something. How am I going to get that second part of my vertex? How am I going to get the y value when I know my x value is 1?
Plug in X.
There you go. We're going to take this x equals 1. To find the rest of my vertex, I'm going to put my axis of symmetry into my equation that I started with and evaluate. So I plugged in 0 to get my y-intercept. I'm going to plug in my axis of symmetry to get the y value of my vertex. So I'm going to make a basic sketch, plotting my vertex, and using the direction to draw some type of parabola. Now, finish the problem for me. I know my range is going to be based on my y value of my vertex. My increasing and decreasing is going to be based on the x value of my vertex. So I just got to decide where my graph is increasing, decreasing, and what its range is. I'm going to draw that graph from the left to the right. My vertex is going to be the point where it stops either decreasing or increasing. It's going to be my relative mid or max is what we're going to call it. It's where my graph changes directions. And to the left of that value is going to do one thing. Less than that value of 1 is going to either increase or decrease, and greater than 1 is going to increase or decrease based on the way the graph looks. So as you finish it up, check it to see what I have. Do not just copy what I have. If you don't agree with me, you don't know why, please send a chat. Let's get it straight before we get out of here. All right, so as you wrap this up, next class, again, we're going to have a great quiz on graphing. You're going to have lines, absolute values, and x squareds, quadratics. You're going to be able to use a table, x and y intercepts, and slope and y-intercept. All right. We're not going to say equal to's on these. If you do, I'm not going to take off. But if you put an equal to, you're going to be telling me that it's increasing at 1 and it's also decreasing at 1. All right, when you put that equal to, it says it's doing both at the same place. And I don't know how a graph can decrease and increase at the exact same place. So if you put equal to's, I'm okay with it. But we're probably just going to do greater than and less than because it can't decrease and increase at the same place. All right, so again, quiz on Tuesday. We'll come in, talk about this homework, do a quick review, or talk about the review, and assign that due Thursday. Thursday after class, you're going to get your test, and that'll be due probably on Saturday at some point. All right, and we'll work it out there. Now, let me do this real quick. Someone just asked where I got my A, B, and my C from. My A is the value in front of x squared. My B is my value in front of my x. And the C is my number. Because if you go back to this formula, ax squared plus bx plus c. A is in front of your x squared, B is in front of your x, C is your number. All right, so I'm going to let you go. If you have any questions, stay back. If not, I will see you on Tuesday. All right, Devin, so if you look at the graph, it's going to be based on the y value of your vertex. If your graph opens up, it's going to be y is going to be greater than or equal to that y value of your vertex. If it goes down, the graph opens down, it's going to be y is less than or equal to that y value of your vertex. It's just looking at the picture. There's not math behind it. You have to pick your y value and decide if you want the numbers above it or below it. Does that help? Okay, I'm struggling. Say that again. I can barely hear you.
It just seems so much easier for y'all, and I thought there was some sort of math behind it, and it got confused.
No, absolutely not. I'm looking right. If you can see what I'm still doing, right?
Yeah.
Okay, so here it's everything above that. So I'm going to say it's all my y's that are greater than -4. If I draw this, which is completely ugly because I'm using my mouse, it's going to be all my y's less than that value. Okay. Yes,
okay.
It's not as bad. I mean, it's just pretty much, that's why I draw the picture, so I can see, okay, that's my lowest y value, and I want everything above it. So I want all the y's greater than that number.
Thank you.
No problem. Have a great one.
Have a nice day.
You too.